Hello everybody, and welcome back to Coffee Break, the show where we break down interesting topics all within the time it takes you to enjoy a few cups of coffee. As always, my name is Clifford Swartz, and I'll be your host for today. And today we'll be talking about e-mobility and all things electric vehicle. We'll be revving up e-mobility solutions. And I have two special guests, one of them in the studio. VJ, how you doing?
Great to be back here, and great to see you again.
Right, so great to be back with these two guests we had in season 2, I believe, and they talked to me all about wireless charging. And today they'll be talking to me all about e-mobility. And the second guest we have through the power of the internet, Mr. David. How are you?
Doing fine, Clifford. How about yourself?
I'm excited. I'm ready. So these two are experts in their field, and we'll be talking more about electric vehicles in a moment. But before we dive into that, I'm going to throw it over to Michael Pierce in the booth, and he's going to tell all of you wonderful people how to participate. How you doing, Michael?
Doing great, and thank you for joining us again live today. I'm actually looking forward to this myself because I actually built an off-road electric vehicle, and I'm actually looking at upgrading some of the controllers and chargers and stuff, so this is going to be really cool.
Right.
Also, a special shout out to those on YouTube. You have helped us pass the 50,000 subscribers list today.
Yeah.
Thank you very much. Yeah. And we love hearing from you. We love you. Please share as well, because we'd love to grow that number to as much as we can. And also, thanks to those on LinkedIn and Facebook as well for joining us. Please share, comment, and keep this growing, because we love that you guys hear about the information we get to you through this media. So,
Right.
Now, please ask your questions in the chat. We will try and answer them on air. We also have some experts online that may answer some of your questions for you. If we can't get to you, email us at livestream@microchip.com, and we will get it to the experts for you, and they will get back to you, and back to you.
Cool. Thank you very much, Michael. So diving right into it, VJ, do you mind giving our viewers who may not know, but also those who know, just a refresher on what e-mobility means and also Microchip's place in the e-mobility industry?
Yeah, absolutely. So we are seeing a major shift in the automotive and the transportation industry,
Right.
as we see a shift from traditional gasoline vehicles to electric vehicles. So while there are obviously some benefits, there are also some challenges that need to be addressed.
For sure.
From a standpoint of power conversion, power generation, distribution, and essentially control of high power.
Right.
So Microchip essentially provides a range of e-mobility solutions for essentially power conversion, for motor control, and solutions that support extended operating or robust environments, and also support functional safety requirements.
Right. And so the first thing that you mentioned on that third bullet point is power conversion. I know that is a huge thing for just regular gas-powered vehicles, and it must be exponentially more so for electric vehicles, right?
Absolutely right, yeah. So power conversion is one of the most important parts in any electric vehicle, if I would say.
Right.
So typically in any electric vehicle there are several voltage rails, right? And then as a result there are several power conversion stages. So typically in each of these power conversion stages you want to maximize the power efficiency and minimize thermal dissipation.
Mm-hmm.
So energy conversion is key here. So several applications such as the onboard chargers convert the AC from the grid to DC to charge the battery.
Right.
And then there are DC to AC inverters essentially that convert the DC voltage from the battery to AC to power any of the other motors in the vehicle. And also the voltage of the battery is in the range of 200 to 800 volts.
Which is massive compared to all the other electronics, right?
Exactly, and you need to
Right.
step that voltage down to in the range of 12 to 48 volts for things like headlight power and
Right.
for in-cabin lighting and for powering seats and doors and windows and things like that. So all of these power conversion stages are very critical in these electric vehicles, and power efficiency and power conversion is key in these applications. And what you're saying here is that DSP solutions and the DSP controller essentially create optimized high-efficiency power conversion solutions.
Nice. And so another thing that we mentioned and had up on the slide is motor control.
Yeah.
That's another huge thing in regular vehicles, but when we're dealing with, we're so integrally tied to the power of the vehicle, I feel like motor control is even more important, right?
Absolutely right. So in electric vehicles, typically electric motors are augmenting mechanically powered propulsion systems.
Right.
So several components such as the AC compressor, automatic doors and windows, and fuel and oil pumps all require motors. Actually, on this slide, what we've done is we've just segmented the different motors inside the car based on whether they're part of the interior, part of the exterior, or part of the under the hood applications. So again, several of these applications, they need to be optimized for efficiency. And that's where the DSP-based solutions, the DSP controller and the system solutions for motor control that we've developed help in terms of optimizing efficiency.
Right. And so on the slide, we broke down, like you said, interior, under the hood, and exterior. And there's quite a lot. And honestly, if we wanted to deep dive in more, we could find vehicles that used even more motor control. And so if those aren't efficient, then all of a sudden the efficiency, the cost of driving, and the overall driving experience goes down, right? And so it's so important.
Absolutely right, Clifford. Yeah, absolutely. So yeah, I do want to mention that the DSP is essentially designed for DSP operations and real-time control.
Right.
Essentially, this combination helps a very reliable and efficient implementation. So there are several PWMs and ADCs and comparators and op-amps in the DSP that essentially help optimize control loop execution time with minimum intervention from the CPU. And essentially what this does is it frees up CPU's resources to run algorithms such as the field-oriented control for controlling motors such as the PMSM motors. And these algorithms essentially optimize the motor control efficiency for the system.
And so, I don't know, sorry.
No, just one more thing. And then in addition, because of the fact that we have extra bandwidth available for the CPU, we can also run functional safety algorithms in the CPU.
And so it saves you time, it saves you money if you want to think about it in a different way, that it cuts down on your bill of materials, your BOM, right? Because you don't have to add an ADC if you already have one. You don't need another PWM if you have one on the CPU that you're already using, right?
Exactly right, exactly right. And also from a thermal dissipation standpoint, because of the efficiency, you don't need to add a lot of heat sinks and things like that.
Absolutely. These. And so it all sort of contributes. It's all good.
Exactly, yeah.
And so I know from previous live streams, previous coffee breaks, that functional safety, and like you've mentioned, is sort of a huge thing in automotive and just about everything these days. Do you guys mind taking a deep dive with me into what functional safety means for electric vehicles and what Microchip's doing to help?
Yeah, I can address that question, Clifford. So Microchip's been a supplier in automotive for more than 25 years, so we have a long history of providing components that are qualified to the AEC Q100 standard, and functional safety is a little more newer, but we do have a lot of experience working with that. So the DSP that we've been talking about today, that's one great example. It's qualified to the Q100 grade 0 spec, which means it can operate up to 150 degrees C ambient. And for functional safety, we can provide all the collateral and data that customers need to get their system certified to ISO 26262. So we can provide FMEDAs, functional safety manuals, other data. We have diagnostic libraries that are compliant to ASIL B and ASIL C, and we have compilers that are also certified. So we can help you get your design functional safety compliant, either with data, collateral, or technical expertise if needed.
Right, but whatever you guys need, looks like we're there for you as far as functional safety and everything else, right?
Right.
And so we've been talking a lot about the DSP, but there's lots of other Microchip parts in electric vehicles. David, do you mind walking me through what else we can expect to see Microchip solutions in?
Sure. Today we focused on DSP, as I mentioned, but there's a whole host of components that can be used in electric vehicle applications. Too much that we can couldn't cover in one coffee break.
Right.
But you see on the screen here, there's some examples of some applications in a typical electric vehicle, and some of the areas where Microchip can support you. So we have various analog components, power management, signal conditioning, things like that. We have networking and connectivity components that can be used, security, temperature sensing, just a lot we can offer. So, we can help you build, a complete system if need be.
Right. So where can the people go if they want to learn more about e-mobility and automotive in general?
With respect to the DSPIC that we're talking about today, if you go to microchip.com/DSPIC-e-mobility, you'll find more about the e-mobility solutions that the DSPIC can support. And then in general, if you want to find out about our automotive solutions, just go to microchip.com/automotive.
Cool. Nice. Simple. So we're going to have all the links that we mentioned and are going to mention in the Q&A section in a bit in the description and in the comments. And if you guys don't see them, feel free to email us at livestream@microchip.com, and we will make sure that you guys get those links. But for now, I'd like to give a huge thank you to our two guests. Thank you very much for coming back on. You're very brave. I appreciate it. And
thank you for having me. Yeah.
Absolutely, whenever you guys want, you're welcome back. But that brings us to the end of the presentation, and so I think we're ready for questions, Michael. Nice.
We do have a couple of questions.
Oh, you're muted.
Yes, we are live.
Sorry.
We're genuinely live. So, things happen.
Yeah.
So, yes, we have a question from Enrique. How are you doing anything with the DSPIC to address cybersecurity?
So
Yeah, that's a great question, actually. So the DSPIC, essentially, we've paired it with a device called the ATTA100 device, which was recently released by Microchip to help solve some of these cybersecurity requirements. So the DSPIC includes hardware features such as code guard flash security and a flash configurable as OTP. And in combination with the TA100 device, it can implement features such as secure immutable boot. That is very critical in some applications.
absolutely.
And in addition to that, it also helps with secure CAN communications. And if you want to have any cloud connectivity from your vehicle, you can have secure cloud connectivity. And it can also be used for like IP protection for any specific intellectual property that you would like to protect.
Right.
So there are a lot of really good benefits when you combine the DSPIC device with the TA100 secure device.
Good question, guys.
Yep, and we have another one from Nadine. Does Microchip have products in EVs that are on the road today?
So,
Yeah, I can tackle that question from Nadine. So we've been working with all the major EV manufacturers, and we do have a lot of products on the road today. As an example, the Tesla Model S has more than 25 microchip components in it. We've been working with Revving, who will launch their vehicles later this year, their truck and their SUV, and we have more than 24 components that are going to be used in those vehicles. And we've worked with companies like NIO, Lucid, and then all the traditional automakers that have electric vehicles on the road today. So the big three in Detroit and the European, the Japanese automakers that have launched their versions of electric vehicles use microchip components because we have a really long history with all those guys. So there's quite a few on the road today.
nice.
Yep, so we have one from, and I apologize if I announce your name wrong, Akilish. He's trying to learn more about the CAN protocol. Can you give him an idea of some good controllers that have CAN?
So we do have, I don't know if we'll rattle off a bunch of part numbers, but we do have a pretty broad portfolio of CAN controllers and CAN transceivers. We have standalone controllers. Most of the controllers you'll find integrated in with the microcontroller, but we do have standalone controllers and then the transceiver products. But if you go to microchip.com/automotive, there's a section for products, and it talks about all of our connectivity products, and there's a page for CAN. And you can see everything we offer from the microcontrollers with CAN controllers integrated, the transceivers, and all that.
Cool.
Yep. And we have a question from Espen. What are some of the challenges that you see working with EV OEMs?
One of the big challenges, I think, is that there's a lot of new players. We're used to working with the traditional automakers, and as I mentioned before, have been for more than 25 years. But when you start talking about EVs, there's a lot of new players. So I mentioned Tesla; they've been in for quite a while now. But some of the others, Rivian, NIO, Lucid, they're still getting their legs underneath them. So there's a lot of challenges about things that they don't know yet. Things that the big guys have, from their decades of making cars have learned already, things that to do with quality, logistics, supply chain, things like that. So I think that's been one of the biggest challenges, is that a lot of these guys, they speak a different language, and they've got some things to learn yet, and they'll learn, and their suppliers like Microchip will help them learn. But I think that's probably the biggest challenge right now.
Yep. So we have another one from Mohammed. So do you think there will be excessive use of mobile charging stations in the future too? And with the mobile charging stations that are already out, is Microchip taking part in that too? So I think there's two parts to this question. It's like the mobile charging stations, like the ones that are in a truck to charge an emergency, and also the charging stations that you pull up and charge into. Are we in those?
Right.
Yeah, we are. There's a lot of different companies that develop the chargers. They're not necessarily the same ones that are making the EVs, but we are engaged with all of those guys. We do have solutions. The DSPIC that VJ has talked about, it's one component, but there's a lot of high power components that can be used in those charging stations. Connectivity is another thing, so Ethernet, CAN, those sorts of devices can be used in those stations. And it's definitely going to keep growing. There's going to be more of the charging piles, popping up everywhere. More EVs are going to be sold, so more of the the home chargers that people plug into their garage walls.
Right.
They're going to keep growing, and so it's a huge market, and we are participating.
And we have one last one from Harasha, and I think it was answered earlier, but it's probably worth repeating. What features of the DSPIC make it advantageous for high efficiency motor control?
I think that's a VJ question.
Yeah. So I can touch upon it again. So essentially, the DSPIC core and the peripherals are optimized for high efficiency motor control. So for example, some of the peripherals like the ADCs and the PWMs and the comparators and the op-amps can work, if I would say, independently to essentially optimize control loop execution time and free up the bandwidth of the CPU.
Right.
And the CPU can run algorithms such as the field-oriented control for PMSM motors. And this algorithm essentially optimizes the efficiency of the motor.
Cool. Good question. Any last one?
No, that's it actually. So
Cool. Well, if we missed it, or if you guys are still thinking or typing, just email us at livestream@microchip.com, and we will hunt these two guys down and make sure they get back to you. But I guess at this point, I'd like to give a huge thank you to our two guests yet again. A thank you to everybody in front of, behind the camera. It takes a whole team to do this. A quick note of housekeeping before I do the official sign-off. This is our third season of Coffee Break, so there's been quite a few episodes. And if you guys want to catch up on any of them, you can always go to microchip.com/livestream. And all you need is 20 minutes. We have a handy-dandy playlist, and it's the perfect thing to perk up your day. And that is the second time I've used that joke, and I promise you that I will have a fresh one in 2 weeks. Anyway, super easy. Check out all the links. We'll make sure that you guys have everything you need. Stay happy, stay healthy, and in 2 weeks I'll be talking to you all about 5G and the wonders of that. So thank you guys very much. See you.
Thank you. Thanks.